Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Integrate the following with respect to x, right? And we've got x plus 4 the whole power 5 plus 5 divided by 2 minus 5x the whole power 4 minus cosecant square 3x minus 1, right? So far, if you have taken a look at some of my previous videos, we would have solved problems of the type y equal to integral of f of x dx, right? And then we moved ahead and solved problems of the type y equals f of ax plus b as an integral of f of ax plus b dx, right? And we solved all those problems by a simple substitution. Now, in this particular video and in some of the subsequent videos that we are going to see, we are going to look at problems of the type y equal to f1 plus f2 as an integral of f1 of x plus f2 of x. And you will have to remember that the sum rule of integral calculus is very similar to what we saw in differential calculus, right? Under the sum rule of differentiation. So I'm going to write that down first, right? So the way we write this is very simple. Y equals integral of f of x, and let's assume we have another function, say g of x, right? That becomes equal to, we have our dx here. Let me bracket this. Now this becomes equal to integral of f of x dx plus integral of g of x dx, right? So this is what the sum rule in integral calculus states, and the problem that we have on our screen is something very similar to what we have written just now as the sum rule in integral calculus, right? And then I want to draw your attention to some of the earlier problems we have solved in the videos that appeared earlier this week. I want you to notice very closely the type of functions that we have solved, right? The type of functions that we would have solved is of the type y equal to f of ax plus b, right? So, and you would have solved them by the method of simple substitution, and I'm not going to be doing that every time. And instead, I want you to remember, if integral of f of x dx equals g of x plus c, right? Then my integral of f of ax plus b dx equal to 1 by 8 times g of ax plus b plus c, right? You don't have to necessarily memorize it, but what happens is when you have these large problems, right, then you can solve them by the method of substitution, but then it's very useful if you can kind of familiarize yourself with this particular formula what I have written here, right? So let me bold it. Yeah, so we're going to be using these two formulas what I have written here, right? Or I can say these two rules what I have written here, they're not exactly formulas to solve some of the upcoming problems in this and the subsequent videos, right? Now we've got, looks like we've got three functions, right? And I want you to draw a parallel to what we have learned in first principles. For example, the first and the second function are of the type x to the power n. So what is that formula that immediately has to come to your mind? That formula that immediately has to come to your mind is this, right? We write it down. Integral of x to the power n dx equals x to the power n plus 1 divided by n plus 1 plus c, where c is any arbitrary constant. So we have x plus 4 the whole power 5, right? So I want you to connect this formula, which I will highlight in yellow, with this particular rule what we learned just now, and we have solved similar problems in our earlier videos using substitution. And I want you to connect both to uh, write down the integral of x plus 4 the whole power 5, right? So what would that be? So this is a function of the type ax plus b, and in place of a you have 1 because ax plus b, if I equate it to x plus 4, then my a equals 1, my b equals 4, right? So therefore, I'm going to write it down like this, right? So if I draw a parallel to what I've highlighted in green, my a equals 1, my b equals 4, right? And then what is my f of x? My f of x is nothing but of the type x to the power n, right? So I want you folks to connect this with the formula highlighted in yellow, right? So all that I do is 1 by a, where my 1 by a is 1, so I write it as it is. And then I have g of ax plus b plus c, right? So what is my g of x? For me to arrive at g of ax plus b, I need to know what is my g of x. And what is my g of x? My g of x is nothing but integral of f of x dx, right? Which is nothing but x to the power n plus 1 divided by n plus 1, right? And in place of x, I have x plus 4, right? Which is my ax plus b. So what do I write this as? 1 divided by a is 1 divided by 1. And in place of x, I replace it with ax plus b, x plus 4 the whole power 6 divided by 6, right? Because 5 plus 1 is 6, right? And then I have an arbitrary constant, right? So this is my step one, right? And then what is my step two? My step two, I have 5 divided by, we take the next function, 5 divided by 2 minus 5x the whole power 4, right? So we need to figure out what is the integral of that. So let me go to the next line, right? So this is what I have. My apologies, I missed dx here. Very important that I mention dx in all my integrals. So I have 5 divided by 2 minus 5x the whole power 4, which is nothing but integral of 5 into 2 minus 5x the whole power minus 4 times dx, right? So let's write that down. And again, an application of the formula that I highlighted in green, where we have, if integral of f of x dx equal g of x plus c, then integral of f of ax plus b dx equals 1 by a times g of ax plus b plus c, right? So I have a function of the type f of ax plus b, which is my 2 minus 5x, right? Or I can call it minus 5x plus 2, where my a is minus 5 and my b is 2, right? So I repeat, 2 minus 5x is nothing but minus 5x plus 2. And if I equate it to ax plus b, then my a is minus 5 and b is 2, right? So that becomes equal to 1 by 8 times g of ax plus b plus c as an integral of that particular function, right? So I need to figure out what is my g of x, right? My g of x is again what I have highlighted in yellow, which is x to the power n plus 1 divided by n plus 1 plus c, right? So let us apply the same formula. In place of x, I have 2 minus 5x, right? Which is my ax plus b. So my 5 remains as it is. My 2 minus 5x, I write it as it is first. And then my x to the power n plus 1 becomes minus 4 plus 1 divided by again a minus 4 plus 1, right? And then I will have to remember my 1 by a here, right? And what is my a? My a is minus 5, right? So I need to put my 1 by a somewhere here, which is my minus 1 divided by 5. Why is that? Because my a is minus 5, right? So I know that the 5 and 5 will get cancelled, and I will be left with minus 1 divided by minus 3, which is nothing but a 1 by 3, right? So I have 1 by 3 times 2 minus 5x, the whole power minus 3. So this is what I have. Right? This is my answer for the second part. Both of them are basis the formula highlighted in yellow, integral of x to the power n dx. Now I go to the third part, I have a minus cosecant square 3x minus 1. So let's write that down. This looks like a trigonometric integral. So let's connect it with one of the trigonometric identities what we have learned under differential calculus, right? Again, I want you to draw a parallel to what I have highlighted in green, right? So f of ax plus b dx, integral of f of ax plus b dx equal to 1 by 8 times g of ax plus b plus c, right? And in place of ax plus b, I have 3x minus 1, right? Which means my a equal to 3 and my b equal to minus 1, right? And my f of x here in this case is a minus cosecant square x, right? So what is that integral formula that I need to use? This is what I have, integral of cosecant square x dx equal to minus cot x plus c, right? Which means I multiply by a negative on either side. So integral of minus cosecant square x dx equal to plus cot x plus c. And then again, I go back, use the formula what I have highlighted in green, and then minus cosecant square 3x minus 1 is what I have. My 1 by a is nothing but 1 divided by 3, right? 1 divided by 3 is my 1 by a, and then g of ax plus b is nothing but cot of 3x minus 1, right? Again, I have my constant. A quick way to check if you've done everything right is to differentiate the answer what you have for each of these uh, antiderivatives. Right now we have all the three antiderivatives with us. Now I go up and then I apply the sum rule, right? Integral of f of x plus g of x dx equal to integral of f of x dx plus integral of g of x dx, which means that it's not applicable for just two functions, it is applicable for n functions, right? So when I put back my answer here, okay, so what I have been asked to find is, let us use this particular line itself. I've been asked to find integral of this, right? Let me bracket it. And when I apply the sum rule of integral calculus, I know that I have worked out the individual integrals. I can just pull them up and my final answer as a sum of three antiderivatives, right? I'm ignoring the constant c. I will come to that when we finalize our answer. All I'm doing is picking up whatever we have worked out earlier. But each of these functions, right, I've got constants, right? So I can sum up all the constants and express them as one single constant, which is plus c, right? So this is my final answer. I have my y equal to x plus 4 the whole power 6 divided by 6, which is nothing but the antiderivative of x plus 4 the whole power 5, plus 1 by 3 times 2 minus 5x the whole power minus 3, which is nothing but the antiderivative of 5 divided by 2 minus 5x the whole power 4. And then I have plus cot of 3x minus 1 divided by 3, which is nothing but the antiderivative of minus cosecant square 3x minus 1. And then I have my arbitrary constant. So that's the final answer to our problem. So let me highlight it in pink. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.